To sketch the graph of the hyperbola with center at the origin, we first plot the vertices 4, 0 and negative 4, 0, and the endpoints of conjugate axes 0, 3 and 0, negative 3. Then, draw or construct a rectangle as determined by the vertices and the endpoints of conjugate axes. Now, why do we need to draw this rectangle? Mahalaga ito kasi sa pamamagitan nito, madidetermine natin ang asymptotes ng hyperbola. The lines containing the diagonals of this rectangle are the asymptotes. The equation of this line is y equals 3 over 4 times x. Remember that if a line is rising from left to right, the slope is positive. A line that slants down from left to right has a negative slope. These asymptotes serve as our guidelines to sketch the branches of hyperbola, keeping in mind that the hyperbola will not touch its asymptotes. We draw a smooth curve, and this is now the graph of hyperbola. Bear in mind that the hyperbola will never cross the asymptotes. The graph just gets closer and closer to it, but never actually touches them. The foci are 5, 0 and negative 5, 0. And the directrices are 16 over 5 or 3.2 and negative 16 over 5 or negative 3.2. And we now have the graph of the hyperbola x squared over 16 minus y squared over 9 equals 1. Another example. Let us also find the center, principal axis, vertices, endpoints of conjugate axes, foci, asymptotes, eccentricity, and equations of directrices of the hyperbola 25y squared minus 36x squared equals 900. First, reduce the equation in standard form. Para maging 1 dito sa right side, we divide the equation by 900. So we have y squared over 36, 25 over 900 is 1 over 36 minus x squared over 25. 36 over 900 is 1 over 25 equals 1. So letter A, the center is at the origin. Since nauuna ang y squared kaysa x squared, the principal axis is the y-axis with the equation x equals 0. The vertices are 0, plus and minus a, since the principal axis is the y-axis. These are the foci, endpoints of conjugate axis, directrices, and asymptotes. But first, determine a, b, and c. A squared is equal to 36, while b squared is equal to 25. Therefore, a is equal to 6, and b is equal to 5. Thus, the vertices are 0, plus and minus 6, which are 0, 6, and 0, negative 6. While the endpoints of the conjugate axis are plus and minus b, which is 5, then 0, and these are 5, 0, and negative 5, 0. Now to determine the foci, we solve for c. A squared is 36, and b squared is 25. Square root of 36 plus 25 is equal to square root of 61. And this value is approximately equal to 7.8. Therefore, the foci are 0 plus and minus c, or 0 plus and minus square root of 61, which are 0 square root of 61 and 0 negative square root of 61. The asymptotes are y equals plus and minus a over b times x. A is 6, while b is 5. So the asymptotes are y equals 6 over 5 times x and y equals negative 6 over 5 times x. The eccentricity is equal to square root of 61 over 6, or approximately equal to 1.3. While the equations of the rectrices are y equals plus and minus a squared over c, or plus and minus 36 over square root of 61. Rationalize the denominator, so we multiply the numerator and denominator by square root of 61. 36 times square root of 61 is 36 square root of 61, and square root of 61 times square root of 61 is 61. We just cross out the radical sign and copy the radicand 61. This is approximately equal to 4.6. Sketch the graph with center at 0, 0. The vertices are 0, 6 and 0, negative 6, while endpoints of conjugate axis 5, 0 and negative 5, 0. Next, draw a rectangle. Then the asymptotes. Thus, we can now sketch the curves of hyperbola. Take note, we draw the curves at each vertex separately. These are the foci 0, 7.8 and 0, negative 7.8. And these are the directrices y equals 4.6 and y equals negative 4.6. And this is the graph of y squared over 36 minus x squared over 25 equals 1. Example number 3. Find an equation of the hyperbola with center at the origin, focus at 5, 0 and a vertex at 4, 0. Sketch the graph. First, let us plot the given points to determine the principal axis. The center is at the origin. One of the foci is at 5, 0, and one of the vertices has coordinates 4, 0. Since the vertex and the focus are on the x-axis, the principal axis or focal axis is the x-axis. And we use the equation x squared over a squared minus y squared over b squared equals 1, where a is equal to 4. Since the center is at the origin and one of the vertices is at 4, 0, we can determine the other point which is at negative 4, 0. And the distance from the center to any of these points is 4 units. Thus, a is equal to 4, while c is equal to 5. One of the foci is at 5, 0. Therefore, the other point is at negative 5, 0. The distance from the center to one of the foci is 5 units. That is why c is equal to 5. We need to solve for b. If c squared is equal to a squared plus b squared, we can derive the formula to solve for b. On the right side, we have b squared, and on the left side, we copy c squared. We subtract a squared to both sides of the equation. That is why we have here minus a squared. Or we transpose a squared to the left side, thus from positive a squared to negative a squared. So b squared is equal to c squared minus a squared. C squared is equal to 25, 5 squared is 25, while a squared is equal to 16. 4 squared is 16. 25 minus 16 is 9. Therefore, b is equal to 3. Square root of 9 is 3. Since b represents the endpoints of conjugate axis, we have 0, 3 and 0, negative 3. The equation of the hyperbola is x squared over 16 minus y squared over 9 equals 1. 4 squared is 16, while 3 squared is 9. To sketch the graph, draw a rectangle, then draw diagonal lines through the center and the corners of the rectangle that extend beyond the rectangle. This gives us two lines that will be our asymptotes. At each vertex, we draw a smooth curve. To determine the directrices, we use x equals plus and minus a squared over c, which is equal to 16 over 5 or plus and minus 3.2. So we have x equals 3.2 and x equals negative 3.2. And this is now the equation and graph of problem number 3. Another example. Find an equation of the hyperbola given the length of latus rectum 8 over 5 and the vertices have coordinates 0, negative 5 and 0, positive 5. First, plot the points 0, negative 5 and 0, positive 5. Since the vertices are on the y-axis, the focal axis or principal axis is the y-axis. And we use the equation y squared over a squared minus x squared over b squared equals 1. A is equal to 5. The distance from the center to each vertex is 5 units. Since we have the length of latus rectum, which is 8 over 5, we can determine the value of b. Recall that the length of latus rectum is 2b squared over a. We substitute the value 8 over 5, which is the length of latus rectum, copy 2b squared, and replace a with 5. We cross-multiply 2b squared times 5 is 10b squared, equals 8 times 5 is 40. Divide the equation by 10, we have b squared equals 4. 40 divided by 10 is 4. Therefore, b is equal to 2. Square root of 4 is 2. Thus, the equation of the hyperbola is y squared over 25, 5 squared is 25, minus x squared over 4, 2 squared is 4, equals 1. And that is all about hyperbola with center at the origin.